So in this case, we had a similar question from the previous examples that we had of the questions which can be given in this format, whilst you are working with a hyperbola, the one that you are used in the form of a over x plus p plus q. This is the same thing, same format. So they were given that the sketch of f of x is given. All right, that is what we have here. And we have got our asymptotes in this case, all right, which we are not given their values. And the A and B being the intercepts. A, the x-intercept, B being what? The y-intercept of what? Of f. So from that, we are given first, write down the equation of the vertical asymptote of what? Of f. Equation of what? The vertical asymptote. So if we are to consider the vertical asymptote, remember that is when you are considering the equations of x is equal to something, all right? Vertical x is equal from this x plus p. X will be equal to what? Minus p. That's what? Our vertical asymptote. So in our case, we can see that the vertical asymptote is this part here, but we are not given that value of x there to say the value of x is 1, the value of x is 2, the value of x is it 3 or what? You are not given. So where are we going to have that value of x? From our f of x. If we are to consider the previous questions that we had on that part or where you applied your long division, this and that, you saw that the denominator was remaining the same. It was not going to change, meaning to say from that denominator concept, you can find the value of x for the asymptotes. So x is equal to what? A positive 1. So where we have our asymptote, the value of x is what? Is 1 from the denominator. We can obtain that one. All right, so that was a direct question. That's why they just said write down. There is no even need for a what? A calculation for that. Then 22.2, determine the coordinates of A, the x-intercept of what? The hyperbola. A is what? The x-intercept of the given hyperbola. So determine that x-intercept, where we do understand that for the x-intercept, all right, for the x-intercept, y is equal to what? 0. So thus you can determine the coordinate of the point A by taking this is equal to what? 0. So you're going to have 2 plus x over x minus 1. Just like before, solve for x. The x-intercept is when you are what? Calculating the value of x when y is equal to 0. So we can do that, all right? If you cross multiply 0 times any number, that's a 0 here, then 1 is going to multiply 2 plus x, all right? So that's 1 times 2, which is 2, 1 times x, which is x. So you can calculate the value of x. 2 to the other side was going to be what? A negative 2. So that's negative 2 is equal to x. So therefore, the point A, which is our x-intercept, can be written as what? Negative 2, 0, when x is equal to 2. I mean, when x is equal to minus 2, y is what? Y is 0. So that's the value of x at what? At A, negative 2. Just like that, all right? Let's consider 22.3. Calculate the area of triangle AOB. So triangle AOB. Erase from a horizontal and a vertical line. So that's we are forming what? A right angled triangle from this, all right? If you are to join A to B, all right? At O, which is our origin, we have got what? A 90-degree angle, as we have got horizontal and what? Vertical line. They meet at what? 90 degrees. So the area of this triangle is going to be easier if we have got the point B. All right, so the area of triangle, all right, AOB was going to be easier if we're going to have what? OB, because we're simply going to use what? Half base times perpendicular height. Half of OA times what? Times OB, where you consider the magnitude of OA and the magnitude of what? Of OB. So we have the distance from O to A, 2 units. The negative is just for the point where it is situated, but the distance here, we are talking about what? 2 units, the magnitude. From O to what? To A. What about from O to B? From O to B, it is simply finding the value of y at what? At B, which is the y-intercept in the y-axis. We're talking about what? The y-intercept, where x is what? Where x is 0. So just like how you calculated here your the x-intercept from the point for the point A, you are going to do that for point B. You need that point B. So to find B, in this case, which is our y-intercept, so we have to consider that x is equal to what? 0 for the y-intercept. So y is equal to what? In place of x, simply put what? As 0 in place of x. So that was going to be 2 plus 0 over what? 0 minus 1, which is 2 over negative 1. That's a negative 2. So that's the point B. That's 0, negative 2. At point B, the y value is negative 2. Therefore, the distance from O to B is what? 2 units. The magnitude. Consider what? The magnitude of that. That's distance, the length. So therefore, the area of triangle AOB was going to be half of what? From O to A, how many units? 2 units times what? From O to B, 2 units again. So that is it. This is 1. So 1 times 2, that was going to give us 2 square units. You're considering area measured in what? In square units. Just like that, right? So this is what we had. This is what we had on this part. Then 22.4, that's where we have the format now that we are used to of a hyperbola. Show that f of x can be rewritten as this. This is the basic format that we are used to, where we have to consider our long division, or we can consider by inspection from our f of x, the original function that we are given here. Can we rewrite it in this format? All right, so that was it on our 22.4. So let us just try to consider both methods just for the sake of revision. Remember, originally our f of x was given as x plus 2 over x minus 1. And I told you guys we can use what? Long division concept or by inspection. So using the long division, it was going to be x minus 1, our denominator, into what? Into x plus 2. Then we divide. All right, so the first thing is to divide first term to the first term. So that's x divided by what? X divided by x, which is 1. So you then multiply. 1 multiplies everything here. 1 times x, which is x. 1 times negative 1, which is negative 1. Then do subtract, all right? Do not forget the stages. So subtract x minus x, that's a 0 here. 2 minus minus 1. Take note, you are subtracting 2 minus minus what? 1. So that's 2 plus 1, which is 3. So this is our remainder, meaning to say this whole expression that we are given of x plus 2 over x minus 1 can be written as it's when we divide, we got what? We got a 1 with a remainder of what? A positive 3. So that's positive 3 over what? Our denominator, which is what? X minus 1. So this is it. So that's 3 over what? X minus 1 plus 1. Exactly what we are given here. So that is our f of x can be actually written in that form. All right. So this is from your long division concept. Just like that, you can have your f of x. All right. Let us consider by inspection where we simply have to express, all right, or where we simply have to substitute x minus 1, our denominator. We're going to substitute that one into x in the what? In the numerator. and make sure that you express it as what? As x plus 2 at the end. All right, so let us do that. In place of x, you put what? X minus 1. So this is what you're going to have over x minus 1. But we want to have x plus 2. So from x minus 1, what am I going to do so that the answer will be x plus 2? Am I going to subtract a number here? Am I going to add a number here? So since the number that we need is a positive, meaning to say we are supposed to think about what? Adding. So which number are we supposed to add on minus 1 to obtain what? A positive 2. That is going to be a positive 3. Minus 1 plus 3 gives us what? A 2. So meaning to say this expression of x minus 1, from that expression, I mean, we are simply going to add what? We are simply going to add a 3 so that it gives us exactly x plus 2. If we add this, it's going to be x plus 2. Then simply separate the terms, meaning to say we are going to have the bracket of what? Of x minus 1 as a term, 3 as a term. That's to separate, all right? So it's going to be x minus 1 over x minus 1 plus 3 over x minus 1. So this is it. This is going to cancel. You obtain a 1. So therefore, it's going to be 1 plus 3 over x minus 1, which is giving us our f of x. 3 over what? 3 over x minus 1 plus what? Plus a 1, just like that. You are done. All right, so you see, guys, simple like that, simple like that. Then 23.5, the graph of f of x is shifted such that the point A lies on the origin, all right? So the point A lies on the origin. What are the coordinates of the point of intersection of what? The asymptotes of the new graph. So from the new graph, the point A was shifted, all right? This is what we have, remember. The point A, like this, let us just have it this way. This is what we have. The point A is at what? Negative 2. So it is shifted until it is at the origin, which is what? 0, 0. So ask yourself that the shift that happened from A to the origin represents what? It is in the horizontal line. We talk about what? A horizontal shift. That's a horizontal shift. So where x has to be taken from A, we have to move up to the origin. How many units? The distance between O and A is what? Is 2 units. So the shift that happened in our case, all right, the shift that happened was of 2 units to the what? To the right. 2 units to the what? To the right. X shifted. X is the one that is shifting to the right. So the x is 2. Meaning to say from the point A, which was negative 2, 0, the point A was negative 2, 0. So to shift it to the right, you simply added a 2 on that. It was minus 2 plus 2, which is what? Which is 0. The y value is not affected. So any shift that we are talking about, any point, I mean, that is going to be affected by this horizontal shift, you are simply going to add what? 2 units to it, a number for x. That minus 2, if you take this minus 2 here, it is minus 2 here, you add a 2, you are going to obtain what? A 0. But the y value is not affected. At point A, y is what? Y is 2. At the origin, y is what? Y is also, I mean, at the point A, y is a 0 there. At the origin, y is what? Y is a 0 again. So the y value is not affected at all. It is not affected at all. It is what? Only the x value. So this is how you answer your question from that understanding. They are saying, what are the coordinates of the point of intersection of what? Asymptotes of the new graph. So you're simply going to ask yourself, from the old graph, f of x, what was actually the point of what? Intersection of the asymptotes? From what? F of x. Our asymptotes here, x is equal to what? 1. And y is equal to 1. So the intersection was 1 versus 1. This is from f of x. So from f of x, a transformation occurred where x has to move what? 2 units to x is the one that is moving 2 units to the right. So therefore, the point of intersection for the new graph, right, that we are going to have, the point of intersection of the asymptotes, we are simply going to affect the x value. It was a 1 from the original graph of f of x, but now it has moved 2 units to the right, so we add 2 on that value, whereas our y value is not affected. Y is what? Y is 1. So it is the x which is being affected. It has moved what? 2 units to, it has shifted 2 units to the right. You add, just like -2 plus 2 to obtain what? To obtain a 0. You added that distance of 2 units. So this is the same distance that we are going to use for the x value of what? F of x, to give us the new value on the what? On the new graph. So therefore, the intersection of the asymptotes was going to be what? 1 plus 2, which is 3. The y value remains as a what? As a 1. So this is for the what? For the new graph. That's the what? The point of what? Intersection of the what? Of the asymptotes. So you see, guys, that's how we play around with our functions. It is just a matter of revision. Functions is one of the easiest topics, guys, that you just need to consider a follow-up. You just need to follow up how to answer the questions. So the more question papers that you work with, the more you can understand this topic. So that is it, guys, for now, till we meet again.